Alex and I are going to be solving this problem, an angled launch where a bully, who is Connor, trips me while I'm holding an ice cream, and I launch the ice cream at an angle of 37 degrees at 99.9 meters per second. And here we're trying to find out what the ice cream's highest point, its peak is in the whole, in its trajectory, and then how far it is away from the base of me, from where I was standing.
At that highest point.
Yeah, at the highest point. Okay, so first we have to break up the ice cream's velocities into x and y components, since we need it to solve the rest of it, which Alex will explain later. But so we have to do, since we know that this is 99.9, using SOHCAHTOA rules, which you probably should know, we do cos of 37 times 99.9, which is 79.8 meters per second, which is the x component, and sin 37 times 99.9, which is 60.1 meters per second for the y component. And now I'll pass it on to Alex so he can explain the rest of the problem.
Okay, so the way I solved this basically is I took out this component right here altogether for the most part. Basically, I started off as y is equal to y naught plus v naught t plus 1/2 at squared to solve for the whole time trajectory as if this was point 0 and it would land at the same height. So you do the math, you get velocity initial for the y, which is 60.1, times t plus 1/2 acceleration, negative 9.81, because that's gravity, t squared. There's no y naught because I took out this whole component altogether. You use the quadratic formula and you get times equal to 12.5. That's how long it would take if it were to launch from here and land at that same height over here. Basically, the reason I did this way is directly in the halfway point, it shall be the highest trajectory, ideally. So that'd be 6.125. So you could just take that time and divide it by half. That is the time it will reach that highest point. From there, I took that height and plugged it in, that time, to solve for the height. So you get y is equal to y naught plus v naught t plus 1/2 at squared again. Velocity initial 60.1 times 6.125 plus negative 4.905, which is gravity halved, times time squared. And you do that, you get 184.009. That is the height at the highest point, discluding this 2.5. So you got to remember to add this 2.5 in, which will get you that 186.6 meters. Then for how far it is at that highest point, again, you have the time and you just plug it in for the x component. This is pretty simple because ideally without any wind resistance or anything, there'll be no deceleration. So it's just going to be v0 t because you're not going to have any x initial position nor acceleration. So you get 79.8, which is the vertical velocity initial, times the time, 6.125. That's how long it took to get to that highest point. And you get 488.775 meters. Any questions?
Why do you have to break it into the x and y components?
Well, I mean, our equations do not allow for angles. You can't somehow magically put 99.9 meters per second at a 37-degree angle into an equation. You have to break it down into 2D components. We do not have an equation for 3D, at least yet. There may be one out there, who knows?
Con los terroristas.
The Harlem Shake.